In this video, I will cover the F5 insertion point for an AI application. The first challenge is around the performances and the scaling. Okay, so how F5 will address this pain, this challenge. First of all, it's important to remind you that different building blocks of an AI application. So if you remember my previous video, we have the front-end application, the orchestrator in the middle, the inference service, and the RAG. Okay, so when the end user asks for a question, for a prompt, the orchestrator will send the prompt to the LLM model, and the orchestrator can ask to the RAG some more data, okay, to populate the inference service. And the main requirements for an AI factory are, first of all, improving the ROI by maximizing the GPU utilization. GPU are very expensive. The multi-tenancy, okay, to optimize the usage of the resources. And the last one is to be integrated, certified, supported by vendors, storage vendors, and of course, NVIDIA DPU. And I will cover this point in a few minutes. In terms of solution, you will see that I will cover and I will present different solutions. The big IPs with an S, okay, so the R series and the Veloz. R series is an appliance, Veloz is a chassis. The Nginx could fit, okay, despite it's a small instance, lightweight instance, it can fit in some use cases. And the last one is a big IP Next for Kubernetes, or BNK. So in terms of traffic, you can see the first one is the green one, the number one. This one is between the orchestrator and the inference service when the prompt arrives. Okay, so here it's mainly traffic management across the different services. And the number two in blue is data ingest. A RAG needs data, okay, fresh data, in order to populate the inference service with more data and get a more accurate answer to the end user. So digest data and of course the data query. So the query between the orchestrator and the RAG. Okay, so just as a reminder, I have a question, I ask a question to my application. The orchestrator will ask to the RAG if it has some extra data for this kind of question. The RAG will share some data. It could be a PDF file, could be whatever it is, something else, and everything is sent to the inference service in order to deliver the right answer. So F5 fits in these three insertion points. Let's start with the first one. Okay, so for the high speed, the scaling, the performances, okay, for the different AI training objects. On this slide, you can see on the right side, I have my storage infrastructure. On the left side, I have my data sources, my data, okay, could be, as you can see, picture, video, recording, files, PDF, whatever. We need to enrich, okay, this storage training infrastructure. So of course, in front of the infrastructure, training infrastructure, we can deploy a Veloz, okay, a chassis in front of the infrastructure. And in the middle, as you can see, I took an example of regional POPs. Let's say you have POPs in different region with all the object, okay, large object, and in order to load balance, had performances on the traffic, you can deploy big IPs, R series, in front of these different large object infrastructure in your regional POPs. Okay, so here in the use case, I am in a data ingest use case. The next one is the big IP Next for Kubernetes, or BNK. So here, as you can see, I am in the AI factory again. I have some local data store, S3 buckets, let's say, and I have my different building blocks. The training, the inference are here, okay? So the goal of big IP Next for Kubernetes is to run on the DPU, the NVIDIA DPU. So it's a big IP, running in Kubernetes, running on NVIDIA DPU. So it is very fast, very efficient. We have better performances for the storage cluster. So, and you simplify the networking. okay, to make it simple in few words and few sentences. So as you can see here, my DPU is over there, DPU is over there, and here, and my big IP, my BNK, big IP next for Kubernetes, is running directly in the DPU in order to be very close to the rest of my AI clusters, okay? And I have a different connectivity between them depending on the infrastructure. This is BNK. The second challenge is how to address the connectivity between the different building blocks. Because unfortunately, those building blocks are not located in the same infrastructure, in the same rack, in the same building. Some of them could be in a public cloud, could be as a service. It depends how you consume your LM model. Is it an LM model that I build on premises by my own, or is it something that I rent as a service? So the main challenge is how to interconnect those building blocks together in an efficient way. And F5 is very strong here with F5 Distributed Cloud Platform. And this platform is able to deliver a multi-cloud networking solution. So easily, quickly, thanks to one element called a customer edge. You can see here, a customer edge is a small element to deploy into your building block, okay? We interconnect in few minutes the different building blocks together, and we solve a lot of challenges in terms of, for instance, overlapping, IP overlapping, because in POP1 and POP2, we have the same network. So I have an issue in terms of routing, we fix it. We deliver a lot of visibility, metrics, observability with the platform. So F5 Distributed Cloud, multi-cloud networking is the solution to fix this challenge. I hope this video helped you to understand the two main challenges and the different insertion points with F5.